This is the ELL 101 project. The topic that I have chosen is applications of electromagnetic induction in wireless charging. My name is Yadvender Singh and I am from group number 4. So let's do the breakdown of the circuit. So the circuit of a wireless charger consists of two parts, a transmitter circuit and a receiver circuit. The transmitter circuit is basically connected to the power source and receiver circuit is connected to the device. Both of these circuits are not physically in contact with each other. So this is how the transmitter circuit looks like. So connections and working of the circuit. The circuit works on the principle of electromagnetic induction between two coils. The task of the transmitter circuit is to convert the input electrical voltage into alternating magnetic flux. This is then received by the coil of the receiver circuit. The circuit is constructed to produce high frequency magnetic flux. The center tapped coil is made through 20 SWG enameled copper wire, and the dimensions can be chosen according to the voltage requirements. The transistor reacts as a switching device and oscillates high frequency signal with the help of R1, C1, and C2 resonator elements. Here, LED 1 indicates the presence of the bias. So since the current that goes into the coil is of alternating in nature, the flux produced by this coil also keeps changing continuously. Now this is how the receiver circuit looks like. As we can see, it consists of a completely different coil and is not in contact with the transmitter circuit. The circuit starts with another coil of similar nature to the one used in transmitter circuit. The coil converts the magnetic flux from the transmitter coil into actual EMF using electromagnetic induction. See, since the flux produced by the transmitter coil keeps changing due to its alternating nature, so by Faraday's law, the changing flux through the receiver coil produces an EMF in the receiver coil, which is also alternating in nature. The rectifier converts alternating input to a singly polar oscillating output. Since devices can't be charged with alternating current, this way we get an output with a uniform polarity. This is exactly what is required to charge devices. So in the positive cycle of the produced EMF, the current passes through D1 and then enters the load through the right side and then exits it through the left side and passes through D2 back into the source. In the negative cycle of the source, it enters the load through D4 through the right side again and then leaves to the left side again, now this time through D3 and enters back into the source. This way the direction of current to the load remains constant and we get an output with single polarity. But still, as we can see, the output is rapidly oscillating with a high amplitude. So we pass it through filter capacitors C1, C2, and C3. This is done because the signal at the stage is oscillating very rapidly and this can damage our device. So to decrease the magnitude of oscillation and to make the output more streamlined, we pass it through filter capacitors. So see, when the first cycle starts, the capacitor starts charging till the peak. When we reach the peak, the voltage starts to decrease and the capacitor starts to discharge very slowly. Then the capacitor starts to discharge. When it discharges by a small magnitude, by that time, the input again starts to rise and matches with the voltage of capacitor. Then the capacitor starts charging again without discharging completely. So we get an output like shown here in the image. This process helps in streamlining our input and decreasing the ripples and making it more uniform so that it doesn't damage our device. Now our last component is IC7805 for voltage regulation. IC7805 is a voltage regulator which gives a constant output of 5 volts. The input can range from 7 to 35 volts. The current rating is 1 ampere. The pin 1 is input pin, pin 2 is ground, and pin 3 is the output pin. Now, as we can see, the output from the filter capacitors, when passed through this IC7805, gives us a constant, an output that is constant in magnitude, which is exactly what we need for charging our device, any device. So by using these various concepts, we were able to take an alternating input signal, transmit it across some distance wirelessly, then we received it, rectified it using a full wave bridge rectifier, filtered it using capacitors, regulated it using IC, and then we were able to obtain the optimum constant voltage supply that we can feed into our device. Thank you. That was it from my side.